Welcome to Geometry Transformations Part 1, covering Common Core Standards 8.G.1, 8.G.2, and 8.G.3. A transformation is a movement of a geometric figure, that means triangle, quadrilateral, etc., on the coordinate plane. There are several different types of transformations. We will talk about three of them: rotation, reflection, and translation. This video is going to refer to rotation. And it's important to know that after any transformation, the figure has the same size, area, angles, and line lengths. So what is a rotation? By rotation, we mean it turns around a center. If you look at this, a point that's rotated around this center maintains the same distance, the same radius, all the way around the circle. As you see here, here's a triangle who has been rotated. Typically on a figure, you either are labeled or need to label the points. If this is point A, the rotated figure has point A prime. This is point B, the rotated figure, now this rotates all the way around here, has this point, which is B prime. And if this is point C, the rotated figure has a point called C prime. Now it's important to realize that I'm using the word prime here. And prime is referring to that little symbol. So when you rotate or translate or reflect a figure, the new points of the new shape have the same letter but have the symbol prime beside them. Let's look at this example. We have point D, and it's 0.15. So it's over 1 and up 5. So D is 0.15. Now we're going to do a counterclockwise rotation around the origin. Now it's going to rotate 90 degrees counterclockwise. So remember that counterclockwise is this direction. So D is going to end up in this quadrant right here. Quadrant 1, Quadrant 2, Quadrant 3, and Quadrant 4. So D is going to move from Quadrant 1 to Quadrant 2. As it moves to Quadrant 2, it's going to get new points. Well, since again this is over 1 up 5, this is going to be over 5 and up 1. So this is going to be our D prime. And D prime is going to be 5, negative 5, 1. Notice how these are very, very similar. This was a 90-degree turn. And so that would be the answer to this example. But we're going to go a bit farther. We're going to look at a 180-degree turn. So if I did a 180-degree turn, point D would end up in the third quadrant, Quadrant 3 down here. So let's look at Quadrant 3. It would be over 1 and down 5. And so this would be D double prime. So D double prime is going to be negative 1, negative 5. And D triple prime, which is a 270-degree rotation, would end up in 4. So that would end up right here. So D triple prime would end up being 5, negative 1. Now look at the relationship between these points and see how they all have the same numbers, but their adjusted base is where it's at. So there's some similarity. If you can figure out which quadrant it's in, you can use that information to decide what point it's going to be. Let me go ahead and recap this and review this one more time. If we have a random point P, and P is in this quadrant, let's let our point be 4, 5. When we rotate P 90 degrees clockwise, which puts it here. By the way, this is also would be 270 degrees counterclockwise. The rotation would cause P to change the order of the X and Y. So previously, the original point, P, X was 4, Y was 5. The rotation is going to cause the X to become 5 and the Y to become 4. And it's also going to cause us to look at the signs. since a 90-degree rotation is going to rotate this down into a new quadrant, in this case from quadrant 1 to quadrant 4, you need to realize here that in this quadrant, y is negative, so the point is going to become negative 4. So the point will be 5, comma, negative 4. Your x value is 5, your y value is negative 4. When you rotate it to the 180 degrees, the rule is your point numbers, your point value, your x and your y will stay the same, but since going from P all the way around 180 degrees, it's going to cause it to go to quadrant 3 in this case. Both of these values are going to become negative, negative 4, negative 5, because in quadrant 3, x is negative and y is negative. When we go to quadrant 4, which is a 270-degree clockwise or 90-degree counterclockwise rotation, when P rotates that far, again, we will swap, because it's based on the 90, the numbers. We're going to look at this quadrant, and in quadrant 2, we're going to see that the x has a negative value and the y has a positive value. So our 5 will become a negative 5 and our 4 will become positive. Here's a your turn example. This may be located at the back of your handout in your study guide, so go ahead and turn back to it. Now would be a great time to try this. You're going to take just a single point, point Z, and rotate it 90 degrees clockwise. So you can take Z and rotate it 90 degrees clockwise. This is example 2. In example 2, we're going to take each point and we're going to rotate it 90 degrees. Now, the question here is, does it matter if it goes clockwise or counterclockwise? Yes, it does. In our case, we're going to go clockwise. We're going to go right when we rotate this. So we have point P, and point B you'll see is 1, 1, 2, 3, 4. So it's 1, 4. Point K is 3, 0. Point N is negative 1, negative 2. And point F, if you look at it, is 1, 2, 3, 4, negative 4, 2. And we're going to create, let me erase those, a rotation. We're going to realize that P is going to rotate from quadrant 1 to quadrant 4. So the new P will be 4, 1. Remember, 90-degree rotation, we switch the numbers. And in this case, the y is negative, so that's going to be a negative 1. So I'm going to erase this to keep this kind of clean. And P is going to be 1, 2, 3, 4. Negative 1 is P prime. K prime, get the numbers switch. 90-degree rotation, we're going to go from here, we're going to go down here. So this is going to be K prime. For N prime, the numbers switch. We're going to look at N. And starting in the third quadrant, it's going to move to the second quadrant. In the second quadrant, x is negative. So negative there. So N is going to become negative 2, 1. So this will be N prime. And last we have F prime. Again, 90-degree rotation, the numbers switch. F is going to be 2, 1, 2, 3, 4. And then we can go ahead and draw our new figure. In this example, we will look at a 180-degree rotation. The question stated at the top asks if it matters if it's clockwise or counterclockwise. Since a 180-degree rotation is the direct opposite, it does not matter which direction it is. Just like previously, we're going to rotate each point individually and label them with a prime. And then, after each point is rotated, we will create a new figure. So let's look at these points. We have point F. Point F is 1, 2, 3, 4, negative 4, 2. Point P is positive 1, 1, 2, 3, 4. K is 3, 0. And N is negative 1, negative 2. Now with a 90-degree rotation, our coordinates flip. X becomes y and y becomes x. And then depending on which quadrant it's moving into, we need to look at
positive and negative. With a 180-degree rotation, the coordinates do not flip, but the signs do change. So F, which is negative 4, 2, becomes 4, 2. P, which is 4, 1, becomes negative 1, negative 4. K, which is 3, 0, becomes negative 3, and then 0 just stays 0. And N, again, we plot each of these. Now notice that F is in the second quadrant, so we know it's going to end up in the fourth quadrant because that's 180 degrees around the origin. So let's go ahead and plot that. We go 4 and negative 2. Right. P is in the first quadrant, and so it's going to end up in the third quadrant. And so P is going to become negative 1, negative 4. 2, 3. There's 4. It's P prime. This is F prime. K is going to become over here, which is 180 degrees from where it's at. And N, which is in the third quadrant, is going to move to the first quadrant, which is going to be 1, 2. As you can see, we get our new figure here. Here's example 2. This one's your turn, so you get a chance of doing this. This should be at the end of your packet. Please complete it, and if you have any other questions, we will answer them in class tomorrow, so bring them and ask them first thing.